and we're going to hear from Arif Masuru with the University of Northern Iowa. Eric Miller and I got a chance to talk with him about his research on the basically the whole Arctic distribution of Arctic tundra fires, and I believe this is sort of the first time I've seen sort of a whole Arctic snapshot of wildfire activities in the entire Arctic region, and so it was pretty interesting from that perspective. So Arif, if well, Sarah, if we could get his poster up. Oh, there we go. Okay. And Arif, if you could tell us just a little bit more about the development of this work.
Yeah, sure. Thank you, Randy. So this is my master's thesis work, analysis of the spatiotemporal dynamics of wildfire activities in the Arctic tundra biome using MODIS data from 2001 to 2015. Randy already mentioned this is the first time looking at the planetary scale of these wildfire events observed from satellite. So I had two main objectives. First, I looked at identifying spatial and temporal patterns of this Arctic tundra wildfire intensity and characteristics. And then I used NASA MERA data to analyze the relationship of wildfire occurrence and intensity with the climatic and environmental drivers at three different temporal scales. First at 15 years, then seasonal, that means annual, and then monthly individual fire events. I got data, the climate variables I used, that was surface precipitation, land temperature, soil moisture, evaporation from land, and also I calculated temperature and precipitation anomalies using the baseline from 1980 to 2009. And I had two sets of methodology, one for the spatial and temporal dynamics, exploratory analysis, time series analysis, and then spatial clustering using different algorithms. And secondly, to understand the relationship with the climate with these wildfire events, I developed some regression models and also correlation statistics. And I'm going to talk about the findings now. So if you can see, you can see from the spatial and temporal patterns, most of the wildfire events, they happen between May to October, and also most people in wildfire events also observed in June, July, and August. In some years, the fire season either started early in May, June, and lasted to September, October. And wildfire events are also clustered in states, tend to form localized isolated clusters, often of high intensity. And the vast majority of detected fires were located in Alaska, Canadian North Slope, and northeastern and northwestern Russia. And then the second part of my research was to look at the climate relationship with this wildfire intensity and number of wildfire events. So for the long-term 15-year wildfire activities and climate variability, if you look at the table just below the maps, level 1 statistics show that negative evaporation and negative precipitation and negative precipitation anomaly has statistically significant and relationship with the average seasonal wildfire intensity. This is the result from 15 years period. Then we looked at the level 2, that is the annual wildfire dynamics and monthly climate variability. And we developed regression models and also looked at correlation statistics. And I'm not going to go into detail, but if you look at the multiple regression model on the left, you can see that March temperature anomaly and July temperature anomaly, and also September land temperature and land temperature, all this positive temperature has significant relationship with this number of wildfire events. We also looked at the climatic factors, how they influence the likelihood of wildfire events, and we developed the logistic regression model. You can see that negative precipitation anomaly in February, June, and July have the significant relationship with the increased likelihood of wildfire events. And also, if you can see that on the bottom of that chart, the temperature anomaly in March that is negative, but temperature anomaly in April, June, and October, they're positive values. So that's from the logistic coefficients. So that means that higher level of temperature in these months have the relationship with increased likelihood of wildfire events. And lastly, we looked at the more finer temporal scale, that is monthly wildfire dynamics and monthly climate variability. So we developed the regression models and with two different dependent variables. So for the first regression model, we looked at the relationship of average monthly wildfire intensity with the that month average climatic variables and also preceding 3 months average climatic conditions. So we can see that previous 3 months precipitation, that is negative precipitation, also positive soil temperature, have a significant relationship with the increased wildfire intensity. And for the wildfire events, so wildfire events also dependent on the elevated level of evaporation during the fire months, and also negative soil moisture and previous 3 months soil temperature anomaly have a relationship with the increased number of wildfire events. So from these findings, we can conclude that most important climatic variable is precipitation with the anomalies and also temperature. So decreasing precipitation, surface moisture, increasing evaporation from land during and prior to the month of wildfire occurrence influence substantially both the total number of these wildfire events, also their intensity. And that means that the dry environmental conditions during the winter and spring months make the Arctic tundra highly susceptible to the wildfire events in the summer. And finally, we can conclude that from these findings that with the predicted climate change in 21st century, the occurrences and intensity of wildfires in tundra biome is likely to increase.
Thanks, Arif. That's interesting. I found it interesting that precipitation came to the top of the list in terms of correlated variables with wildfire occurrence more than temperature, I guess, because in the interior boreal forest, it's the reverse. Temperature seems to be much more important than precipitation and predictive of burn acreage. So your whole Arctic study points at precipitation, which under some of the climate models is supposed to increase in this region. So at least in parts of Alaska. So that might be good news for us in terms of tundra fires, what I'm gathering here. Does that sound about right?
Yeah. So I would like to also mention that from these statistics, you also can see that at different level, temperature has also a significant influence, but I really forgot maybe to mention in my conclusion. So I stress more on precipitation, but temperature also have influence. But you also mentioned that the overall precipitation is likely to increase from the models, but there will be also regional variability. In some part, they are likely to increase, but in some part, they will also decrease. So, I mean, that might be something to look at.
Right. I see now the temperature anomaly in June seems to be of the temperature variables that influence fire. June really is at the top of the list, and then followed by October and April, it looks like.
Yeah. Also, if you look at the level 3, the monthly wildfire activities there, so you will see that when wildfire actually happening, you know that from in between May to October. So if you just consider 1 month, May or June, then that month's previous 3 months soil temperature and soil temperature anomaly also has significant relationship with this intensity, also the number of wildfire events. That's what I found from this statistics.
I see. All right. Questions for Arif? Well, thank you. What's the next step in your research, Arif?
So I'm writing a paper from this right now, and I graduated already, and I finished my master's. Then I'm going to start my PhD at Penn State from August this year.
Great. Okay, well, thank you very much for sharing that. And
Thank you.
as people have time, they can take a closer look at the fine print on that poster. Like I said, it's interesting to me that because it zooms up to a larger overview of tundra fire over the entire Arctic region, and it's kind of the first snapshot I've seen of that. Eric, anything else you want to add on that?
No, I was just thinking I wouldn't mind having a copy of that poster. Don't see your email or anything on it. Do you have contact info we can have?
Yeah, I'm in contact with Randy, and
Hi, this is Jessica. I just wanted to let you know you can download the poster from the website. Sarah's showing the page that it's on right now. It's available to any of the team members for download.
Okay, thank you.
I would also note that on the event page, the link is broken, but I'll fix that so you can also find it on today's event page. But the easiest way is to type in Arif's name, but it comes up right here.
thank you.
All right, great.